Hello and welcome to Stories of Science. Here, we look back on humanity's long journey to understand the world. The questions, the failures, and the breakthroughs that slowly changed how we see the universe and ourselves. We tell science as stories. The hidden genius of chemistry, how Gilbert Lewis revolutionized science. If you think chemistry is boring, you probably haven't heard of Gilbert Lewis. He didn't just make chemistry interesting, he changed the way we understand the world. Today, we're diving into the story of the magician who made electrons jump. You may have never heard his name, but every time you use chemistry, especially when studying molecular structures or chemical bonds, Gilbert Lewis's ideas are already deeply ingrained in your mind. Want to know how to build powerful chemical bonds between elements? Lewis's theory is the key to the puzzle. His electron pair theory is like the answer to unlocking the mysteries of chemistry. Sounds a bit dry? Trust me, the story is way more exciting than you think. He showed us that atoms don't just collide like cold, emotionless billiard balls. Instead, they engage in complex and fascinating interactions. So what made Lewis such a significant figure in modern chemistry? How did he manage to make such an impact? The answer lies in his refreshing electron pair theory. You might think it's dull, but trust me, the story has plenty of surprises. Let's take a closer look at how Lewis turned dry, lifeless chemistry into an exciting, imaginative scientific magic show. Gilbert Lewis was born into a modest family. His father, Joseph, was a regular worker, and his mother, Emma, was a gentle housewife. They didn't have a background in chemistry, but they deeply understood the power of knowledge. The family wasn't rich, but from an early age, Lewis showed an insatiable thirst for knowledge. This drive for learning burned in his heart, just like his passion for chemistry. No matter the subject, Lewis always found its charm. His parents, while not wealthy in material things, gave him the most valuable gift of all, the seed of knowledge. That seed took root and blossomed into something brilliant. But if you think Lewis's home was a quiet academic sanctuary, you'd be wrong. His family wasn't one to flaunt its intellectual pursuits, and the atmosphere was always calm and simple. But Gilbert was far from ordinary. He had a unique sense of humor and often brought surprises to family gatherings. Imagine this: the gathering just started, and Lewis stands up, suddenly introducing a conversation with, "So, how do chemical bonds keep molecules together?" At first, the relatives might be confused, but soon enough, they're swept into the conversation by his humor. Lewis's humor wasn't just about cracking jokes, it was about making you think. He could take the driest academic topics and turn them into hilarious stories that left everyone laughing. Who would have thought that a chemist could make a family gathering feel like a scientific experiment? But that was exactly his charm. He could make the most mundane things extraordinary. From MIT to Harvard, Lewis's academic journey was filled with passion and determination. He wasn't the type to settle for the ordinary, he was always chasing more knowledge. Every time he saw a complex formula, his eyes would light up, like he'd just discovered a new world. He always saw what others couldn't: the beautiful truths hidden behind complicated math formulas. Sometimes, in his lectures, Lewis would give his students unexpected moments of enlightenment. Even the dullest topics would come to life with his humor. Imagine sitting in a Lewis lecture, thinking you're about to get lost in a sea of boring theories, then suddenly, he snaps you out of it with a funny metaphor. Chemistry is like a party, he might say. Atoms and molecules are dancing, and the electrons are the stars of the show. Imagine being in a class about molecular structures, and Lewis says that the entire room would light up with energy. He could make a chemistry lesson more fun than a Friday night party. His humor wasn't just about laughs, it was the key to understanding complex concepts. Whenever students faced a tough problem, Lewis would break it down with his special brand of humor. His classroom was always filled with laughter and insights. You think chemistry is a boring subject? Well, you haven't seen Lewis's classroom. He didn't just teach chemistry, he made you laugh while learning. In his class, every formula was a fun adventure, and every reaction was like a lively dance. If you were one of his students, his class would be the highlight of your week. It wasn't just learning, it was a joyful journey of knowledge. Lewis's academic path wasn't a smooth one. This chemistry genius didn't always walk the straight line. He wasn't like the scholars who immediately walked into success after graduation. Instead, Lewis faced several setbacks and challenges. He taught at multiple prestigious universities and went through many ups and downs. But he never gave up. With unwavering determination, he finally secured a spot at UC Berkeley. Imagine, after years of hard work, finally finding his place. At that point, Lewis might have cheekily said, "Now I can finally bring those chemical equations off the paper and into the real world." Of course, that was just his humor talking. He really did break through one scientific barrier after another. However, his career wasn't always a picture of smooth progress. Sometimes, he was so absorbed in his work that he lost track of time. Some colleagues joked that Lewis probably thought time was like a chemical reaction that could be controlled. For instance, if the reaction was too slow, no worries, just add a catalyst. He was probably one of those scholars who forgot to eat or sleep once he got deep into his research. Whenever he was lost in thought, it was like he locked himself inside his chemical laboratory, completely oblivious to time passing. Some would joke that if Lewis could control time, he'd make chemical reactions go faster. Unfortunately, his laboratory wasn't a time lab, but that's exactly how immersed he was in his research. As for his personal life, Lewis kept it relatively low-key. Although he was married and had children, his devotion to his academic work meant that family life was simple and understated. His love for chemistry clearly outweighed his interest in household chores. Can you imagine a chemist who's holding experimental data, calculating molecular structures, while not even thinking about what's for dinner? Yes, that was Lewis. Some said his family life was like his laboratory, orderly but quietly mysterious. He probably occasionally said, "If today's experiment worked, dinner will just sort itself out." For him, chemistry was the most exciting topic. Sometimes, his kids might have commented, "Dad's always in love with chemical reactions." But regardless, Lewis played the role of a quiet, devoted scholar in his family, not the traditional household provider. He poured all his energy into the endless exploration of the chemical world. Maybe, in his mind, his chemistry lab was more thrilling than any family gathering. In the end, Lewis's life, like his chemical reactions, was full of energy and drive. He gave different amounts of energy to both his academic work and his family life, though academic work often took the lead. But that was part of his unique charm. Lewis's personality might seem a bit introverted at first. He wasn't one to show off or stand out in a crowd. If you met him at a party, you might find him quietly sitting in the corner, reading a book. He didn't like loud environments, and socializing wasn't his forte. But if you started talking chemistry, his eyes would light up like he'd discovered a new world. His introversion contrasted sharply with his passion for chemistry. Don't be fooled by his quiet demeanor. His academic fervor was impossible to ignore. The term academic fanatic might best describe him. If he could immerse himself in an experiment, he'd forget about time altogether. Sometimes, Lewis would spend hours in the lab, completely indifferent to the outside world. He preferred dealing with molecules and atoms rather than having conversations with people. Imagine a person who's perfectly content chatting with lab equipment all day instead of people. That was Lewis, and his love for chemistry went beyond anything else. Sometimes, academic pursuits took priority over family life. If you asked him, "Lewis, want to join us for a party this afternoon?" he might respond, "Let me finish this experiment first." Chemical reactions are like parties, just add a catalyst for a faster outcome. He always found ways to connect chemistry with daily life. But the most interesting thing about him was his humor. Imagine sitting at a gathering, with Lewis quietly sipping tea. You ask him, "Gilbert, anything interesting happening lately?" He'd smile and say, "Oh, the chemical reactions in the lab were like a passionate dance party. The electrons were really getting down." You might blink and say, "Electrons dancing." And he'd casually explain, "Yep, they're constantly swapping partners between atoms, just like a chemical reaction." He could take the driest chemical theory and turn it into something fun, making everyone around him laugh. And he didn't just do that once, he made chemistry fans out of everyone around him. Even those who had no interest in chemistry would start thinking about its mysteries, all thanks to Lewis's infectious humor. He could take complex concepts and make them exciting and easy to understand with simple words. This wasn't just academic wisdom, it was a power that sparked curiosity and a love for science in others. Imagine if Lewis were your chemistry teacher. His class would probably be more entertaining than any reality show. You'd probably want to learn even more fun chemistry tricks from him. In the end, there was a perfect balance between Lewis's introverted nature and his humor. He was quiet, humble, but his passion for chemistry made everyone around him fall in love with it. He didn't need to speak loudly to grab attention. All he needed was a little humor and a few words to show you the magic of chemistry. For Lewis. In 1916, Gilbert Lewis introduced his electron pair theory. The moment this theory hit the scene, it instantly transformed our understanding of chemical bonds. In simple terms, chemical bonds aren't some mysterious glue that holds atoms together. Instead, they form when atoms link up by sharing electron pairs. Picture this: atoms are like two people who build a connection by exchanging little gifts. And just like that, their bond becomes inseparable. That's the essence of Lewis's theory. Electron pairs are the glue that holds atoms together. No more abstract forces or intangible concepts. Instead, two atoms come together, sharing an electron pair, creating a tight bond that's easy to understand. Think of atoms as two friends swapping their personal belongings, electron pairs, breaking down any walls between them in the process. It's not just a scientific theory, it's a revolution in chemistry. Ever thought of atoms as going on a secret date? These tiny particles, through the sharing of electron pairs, create a kind of unspoken bond. And the social media that connects them? That's the electron pair, as proposed by Lewis. Sounds a bit romantic, right? Who knew chemistry had its own romantic moments? Imagine, if you were a molecule, maintaining a connection with your partner through the shared gift of an electron pair. It's like, hey, I'll lend you an electron so we can stay connected. These silent social contracts are happening every time a chemical reaction occurs. But when Lewis first proposed his theory, not everyone was on board. The response from the chemistry world? Let's just say it wasn't exactly a standing ovation. Some thought the idea of shared electron pairs sounded a little too romantic. Who would have thought that atoms could fall in love and share electron pairs as a bond? But as time went on, more and more experimental data proved Lewis's theory right. Atoms truly do form chemical bonds by sharing electron pairs. This wasn't just theoretical thinking, it was the result of countless experiments and verifications. And so, Lewis's electron pair theory slowly gained ground, becoming one of the foundational concepts in chemistry. In this new world, electron pairs are like bridges connecting atoms, allowing them to communicate and form tight relationships. What's even more exciting? The act of sharing an electron pair doesn't just build connections, it also decides molecular structures, reaction speeds, and other chemical properties. So, Lewis didn't just reveal the secret behind chemical bonds, he gave us an entirely new perspective on the chemical world. He opened our eyes to a world full of possibilities with this shared gift. You see, the interactions between atoms are no longer dry, abstract scientific puzzles, they're like human friendships or relationships, full of warmth and connection. Chemistry is not as cold and heartless as we once thought. It has its moments of tenderness. Maybe that's Lewis's greatest gift. He made chemistry not boring, but he made us feel the subtle connections between things, the same kind of connections we feel between people. Who knew that electron pair sharing could be so romantic? After all, it's what forms all the matter and drives chemical change. Now, let's talk about the application of Lewis structures, which was a revolutionary leap in chemistry. In chemistry, we're often faced with complex molecules, atoms, and electrons. So, how do we clearly see how these molecules pair up and form chemical bonds? The answer: Lewis structures. Think of it as the map of a chemical reaction, helping us quickly spot how electrons are arranged in a molecule. Each dot and line in the Lewis structure represents the interactions between electrons, even forming chemical bonds. Using a Lewis structure to represent a molecule is like using a map to mark a city's location. Everything becomes clear. The beauty of Lewis structures is that they simplify complex molecular structures, making them easy to understand. If you've ever studied chemistry, You probably know that a Lewis structure is like the roadmap of chemistry. It helps us navigate through the maze of atoms and molecules, showing how they interact. And Lewis? He's the designer of this chemical map. Through his structure, he gave us a window into the world of molecules. Each Lewis structure is like a vivid map, showing the intricate relationships between atoms. It's not just an abstract theoretical tool, it's something that directly impacts our everyday lives, from drug development to new material design. What's more exciting? Lewis structures not only help us understand existing molecules, but they also let us predict future chemical reactions. It's like getting the script to a play before the actors even step on stage. If you understand Lewis structures, you can easily predict how molecules will behave. For example, you'll know how two molecules will combine in a chemical reaction and how much energy they'll release. All of this can be foreseen through Lewis structures. This simplicity, yet profound depth, has made Lewis structures an indispensable part of chemistry. In the 1920s, Lewis's Lewis structures didn't just help scientists understand basic chemical reactions, they laid the foundation for future chemical research. Imagine those early scientists who could finally decode the complex patterns of atoms and molecules, quickly spotting the patterns and trends. They no longer had to rely on time-consuming experiments to predict reactions. Lewis structures gave them almost superhuman powers. From then on, chemistry entered a new era. Chemical reactions weren't black box mysteries anymore, they became predictable and controllable processes. So next time you encounter a chemical formula, remember to thank Gilbert Lewis. He gave us the map to unlock the secrets of countless molecules. Who knows? The next time you're in the lab, you might feel like you're navigating a map, step by step, toward the answer. Lewis's expansion of the acid-base theory was truly an innovative revolution in chemistry. In the traditional acid-base theory, we generally think of acids as substances that release protons, and bases as those that accept protons. While this explains most cases, some strange molecules don't fit neatly into this definition. For example, some molecules can display acidic properties without releasing protons. That's when Lewis stepped in. He proposed a new perspective: acids are not only substances that release protons but also those that can accept electron pairs. Bases, on the other hand, are substances that can donate electron pairs. He expanded the definition of acids and bases from proton exchange to electron sharing. This wasn't just a theoretical extension, it had huge practical applications in chemical reactions. You see, Lewis's acid-base theory made chemical reactions much more flexible. Acids and bases were no longer just proton exchange parties, they became partners in electron pair sharing. Sounds a bit complicated? Don't worry, Lewis's acid-base theory isn't about picking acid or base for your party. It's about learning how to find the right match in chemistry. Picture a chemistry party: acids are like those dance partners willing to accept your electrons, and bases are the ones ready to share electrons. Through electron pair exchange, they form chemical bonds. It's like at a party, two people exchanging dance moves in perfect harmony to create a beautiful dance. Lewis's theory completely changed our understanding of acid-base reactions. Acids and bases aren't just about simple proton transfers, they're all about the exchange of electron pairs, opening up a whole new world of chemical dance steps. And this theory has been crucial in advancing chemistry across many fields, not just in traditional solution chemistry, but in organic chemistry and catalytic reactions. Lewis's acid-base theory has played a pivotal role. For example, in catalytic reactions, catalysts often donate electron pairs to help speed up reactions, something we see directly in action with Lewis's theory. Whether you're making drugs or researching new materials, Lewis's theory provides you with new tools for understanding and predicting chemical reactions. His acid-base theory opened a new path for the entire world of chemistry. And what's more fun, it made acid-base interactions far more exciting, like a lively chemistry dance in the scientific world. So next time you're running an experiment, remember to thank Lewis. He made acid-base reactions feel like a dance party. When quantum mechanics was just starting to take shape, Lewis was already thinking about the future of chemistry. He saw the huge potential of quantum mechanics in chemistry, even though quantum theory was still in its early stages. Lewis realized that quantum mechanics wasn't just a theory about particle movement, it could unlock the real secrets behind chemical reactions. Imagine the 1910s when quantum mechanics was just beginning to emerge in physics, and scientists were busy figuring out how electrons jumped within atoms. But Lewis already saw its applications in chemistry. Like a prophet, he glimpsed the future of how chemistry and physics would merge. His theories laid a strong foundation for later quantum chemistry research. He helped scientists explain the essence of chemical reactions and made them realize that atoms and molecules weren't just simple physical entities, they were complex systems governed by quantum rules. Lewis's forward thinking helped him envision a whole new chemical world. How did he see the quantum picture of chemistry when quantum mechanics was still in its infancy? It's like wearing futuristic glasses and seeing where chemistry was headed. Lewis was always ahead of his time. While others were still struggling with how electrons move in orbits, he was already thinking about how quantum mechanics could unlock the secrets of chemical reactions. He wasn't satisfied with the chemistry theories of the time, he was always seeking new perspectives. Whenever he proposed new theories or ideas, people might have thought, is this too far ahead? But history proved him right. His ideas weren't too advanced, they were the foundation for future quantum. Gilbert Lewis's contributions were nothing short of a revolution in the field of chemistry. His electron pair theory and Lewis structures continue to be central to chemistry education even today. These two concepts have become the very foundation of modern chemistry. They help both students and scientists grasp how atoms come together to form chemical bonds by sharing electron pairs. Without these ideas, our understanding of chemistry would look very different. Imagine this: if chemistry were a movie, Gilbert Lewis would definitely be the director and the screenwriter. He turned every chemical reaction into something alive. What once seemed like boring electron movements became a dramatic, engaging, and full of life process. He didn't just set the rules for how chemical reactions happen. He gave them purpose. He gave them life. In his theory, every molecule became a character in this vast scientific drama. Every electron had a role to play in shaping the story. It's not an exaggeration to call him the director of chemistry. Just like a movie needs a skilled director to keep the plot moving, Lewis set the pace for chemical reactions. With his theory, every process unfolds in an orderly, well-timed rhythm, ensuring that everything happens as it should. And Lewis's influence goes beyond just chemistry. His work extended into the field of biology as well. He played a crucial role in understanding enzyme reactions and even DNA structure. Think about it: when biologists study protein folding, aren't they, in a way, relying on the magic of chemical bonds? How do hydrogen bonds and van der Waals forces hold the two strands of DNA tightly together, allowing life to exist as we know it? These biological puzzles have deep ties to Lewis's theories. His ideas didn't just change the way we look at chemistry, they quietly entered the world of biology, influencing every experiment. Sometimes, biologists might not even realize how deeply chemical reactions are involved in their work, but without Lewis's key to unlocking chemical bonds, many of the major breakthroughs in biology would not have been possible. His theories laid a solid foundation for understanding how large biological molecules, like proteins and DNA, interact and work. Lewis was not just a chemist confined to the classroom. His influence quietly made its way into countless scientific fields, especially biology. This wasn't just a simple crossover between disciplines, it was like a chemical bridge connecting chemistry and biology in a way that hadn't been done before. Thanks to Lewis, chemistry became more than just its own field. It became the essential foundation for biology, medicine, and even environmental science. So, the next time you see a biologist at work in a laboratory, remember their experiments might be quietly guided by Lewis's influence. What may seem like a straightforward biological process could be driven by the same chemical bonds and reactions that Lewis uncovered. Gilbert Lewis's electron pair theory didn't just transform chemistry. It led to groundbreaking advances in materials science. His theories played a key role in fields like catalysis, semiconductors, and the development of new energy materials. Catalysts, for example, are substances that speed up chemical reactions, but the precision of electron pair sharing is what makes them work. Without Lewis's understanding, we wouldn't be able to design the efficient catalysts that are used in countless reactions. The science behind semiconductors is also rooted in the careful control of electrons. Lewis's theory provided the groundwork for scientists to regulate the flow of electrons in materials. This understanding paved the way for technological breakthroughs in electronics, from the simplest LED lights to the most advanced devices. Think about the gadgets and technologies you use every day: LED lights, lasers, or batteries. They may seem like simple tools, but behind each one is the guidance of Lewis's theory. These common items are rooted in the very same principles he introduced. Every time you flick on a LED light, you're seeing his influence at work. What about the future of clean energy? Solar power, wind energy, and other renewable resources are now more efficient thanks to the precise control of molecules and electrons. All of this is made possible by Lewis's theory. His work laid the theoretical foundation for scientists to improve how we harness and use renewable energy. So, the next time you encounter a new environmentally friendly tech product, remember it may be powered by the very theories that Lewis introduced. Without his contributions, we wouldn't have the efficient, clean technologies that help protect our planet today. Even after his passing, Gilbert Lewis's academic influence remains powerful. Modern chemists, especially those working in quantum chemistry, continue to draw inspiration from his work. His electron pair theory helped to build the foundation for the rise of quantum chemistry. This allowed scientists to better understand and predict molecular structures and chemical reactions. Can you imagine? Lewis likely never anticipated that his theories would become essential knowledge for future generations of students. He probably didn't foresee his electron pair theory becoming as fundamental as the multiplication table. Who could have predicted that chemistry would turn into such a fascinating and dynamic field? At the time, Lewis just wanted to make a meaningful contribution to chemistry, but he unknowingly became the cornerstone of an entire scientific discipline. Today, his influence is felt in almost every lab around the world, from quantum chemistry to materials science. His theories are at the heart of almost every scientific discovery, whether it's studying molecules or creating new materials. Every scientist working today is, in some way, building on Lewis's work. If you take a moment to think about it, most of the innovations happening in labs today are deeply connected to Lewis's theories. What was once considered a simple theory is now the backbone of modern chemistry. His work has shaped the direction of countless scientific advancements, from the development of new materials to the study of molecular behavior. Lewis never expected that his name would become synonymous with the guiding principles of chemistry, yet today, his electron pair theory is the North Star for chemists and scientists alike. It's the foundation on which they build their discoveries. Without his contributions, we wouldn't have the deep understanding of molecular interactions that we take for granted today. Gilbert Lewis didn't just unlock the mysteries of chemistry, he opened a new door of understanding, one that reshaped the way we see the world around us. He wasn't just a chemist, he was someone who could take incredibly complex ideas and make them simple and, dare we say, exciting. Through his lens, the tiny interactions between electrons and atoms became a vibrant story, full of energy, drama, and life. Lewis made us realize that chemistry isn't just about atoms and molecules interacting. It's like an art form full of creativity and imagination. If you think that Lewis was just a dry theorist, you might be missing the bigger picture. His work turned those so-called dull atomic interactions into something far more fascinating. Each of his contributions added to the dramatic, ever-evolving story of chemistry. He brought excitement and energy to every chemical reaction, and every molecule had a role to play in the grand narrative. Want to truly dive into the world of chemistry? Don't forget the name Gilbert Lewis. His work didn't just explain the invisible movements of electrons. It showed us that chemistry is everywhere in our daily lives. From the moment you flick on a light to the water you drink, there's a good chance Lewis's theories are at work behind the scenes. So, the next time you come across a chemical problem, remember the giant behind it all. Gilbert Lewis didn't just change the field of chemistry, he changed how we understand the world around us, making it a little more magical and a lot more connected. The people who change the world usually just think one step deeper. If this story made you see things differently, hit like, subscribe, and save it. See you in the next story.